Hello everyone. Now we are going to start with the MCQs of the motion chapter. You can read here question number one. The speed time graph shown is for bus traveling between stops, where on a graph is the acceleration of the bus greatest. Okay, so this is the speed time graph given, and we want to know what is the acceleration. So first of all, let's this figure is attached here for reference. We have learned this figure in while learning the chapter. I have told you the slope is zero when suppose this line for a horizontal line we get the zero slope. If the line is steeper, we get the higher slope, and for the steepest line we get the highest slope. Okay, so as the line is steeper, the slope increases. Okay, and suppose this, if I consider this y-axis is nothing but the speed and the x-axis is the time, then the slope of the speed time graph is nothing but the acceleration, which is shown over here. A is nothing but a change in the velocity divided by change in time. Okay, the slope is the change in y-axis divided by change in x-axis. So here, this we can consider as a speed if the motion is in straight line. So this is nothing but change in speed divided by change in time. So the speed time graph slope is the acceleration, and for the highest steepest line the slope is highest. So here this is the speed time graph, so acceleration is nothing but the slope of this graph, and it will be highest for the steeper line. You can see A is close to horizontal, D is also horizontal, B you can say it is the steepest one, C is also almost horizontal line. You can see this is almost horizontal, this is almost horizontal. It is little bit inclined but not steeper like this B. So D is also somewhat horizontal. So we can say B is only the answer because the slope is acceleration and this is the steepest line. The B is on the steepest line. That's why it is having the greatest acceleration. Now the second question. A tennis player hits a ball over the net. Okay, you can see this tennis player is hitting a ball, and this ball is moving in this kind of trajectory or a path. In which position is the ball accelerating? Okay, whenever there is an object which is moving above the surface of the earth, the gravitational force is acting on it. Okay, and gravitational force is acting at every point. I can select any point over the surface of the earth. The gravitational force is acting at every point. Okay, and therefore the object or mass or ball is accelerating with the acceleration that is close to 9.8 or 10 meter by second square. So I can't say just depending on the motion of the ball whether it is moving up or moving down or moving sideways. Every point it is accelerated because of the force of gravitation. So it is acting also on P, it is acting on Q, on R, every point. Okay, whatever I am drawing these red points, every point it is acting. So all the points it is acting. So only PQ, PR, QR cannot be the answer. It is acting on all the points. Therefore, D is the answer. Now we will see question number 3. The graph shows how the speed of the car changes with the time. Okay. And you can see this is the speed versus time graph. Which of the following gives the distance traveled in the time interval QR? So time interval OR. Okay. This is the time interval. It is starting with O and ending at R. And they are asking us what is the distance, and this is the speed time graph. And we know that speed is nothing but the distance divided by time. So what is the distance? From this formula we can say distance is nothing but speed into time. Speed into time. And always remember, whenever there is a speed time graph, okay, the area under the curve, if you consider this area under the curve, this area is nothing but the product of the x and y. Here y-axis is speed and x-axis is time. So this area under the curve, area under this line, is nothing but speed into time, and speed into time is what? It is nothing but the distance. So we can say this distance is nothing but this is given by the area. Okay, this area under the curve or area under the line. Okay, so if you want to calculate the distance, this area, that is nothing but OPQR, is to be considered, and that is nothing but given in the option number 1. So the area OPQR is the answer. The length PQ cannot be the answer. Okay, PQ, you can see here, PQ is nothing but it is just a line on the graph, speed time graph, which cannot be the area. The length QR minus PO. So here this is QR, this is nothing but PO. This is nothing but vertical line. It is vertical line is nothing but the speed. So speed, QR is a speed, PO is a speed. Speed minus speed will give you only the speed, not the area. Here the ratio QR minus divided by PO. That is nothing but QR divided by PO. So that is also the ratio of the speed that will be in Euclid's quantity. So that cannot be answer. Answer is nothing but the area under this speed time graph. Now we will see the question number 4 over here. Here the question number 4. Aeroplane flies from town X to town Z and stopping for 1 hour at town Y. Okay, at this town Y it is stopping for 1 hour to pick up more passengers. The distance between the towns are given in the diagram. Total time taken between leaving X and arriving at Z is nothing but 3 hours. What is the average speed of the aeroplane in the air? Okay, so you can see it is starting from the X, then it goes to Y. There it is covering the distance of 300 km. At Y it is stopping for 1 hour, then it is going towards the Z. And from Y to Z it is covering the distance of 200 km. And total time it is taking from X to Z is nothing but 3 hours. And since it is stopping for 1 hour, we have to subtract that time, and the total time for journey will be equal to 2 hours only. And what is the definition of average speed? It is very important. The definition of the average speed is nothing but total distance covered divided by total time taken. And here we can see the total distance covered is nothing but, I can write, it is nothing but this 300 plus 500, that will be 300, can write over here. For rough calculation, it is 300 plus 200, that will be total distance covered, divided by total time is how much? This will be 3 hours minus 1 hour. Okay, 3 minus 1. I should write over here 3 minus 1 because 1 hour it is stopping at, that's why I have subtracted the point. Subtracted. Now you can see this is nothing but 500 divided by 2. Okay, so the average speed is total distance covered divided by total time. Total distance covered is 300 plus 200. Total time taken is nothing but 2. So you can see the option number C is only the answer. Remaining are like 500 by 4, 500 by 3. Do not confuse with this. Okay, the total time taken is 3, but it is stopping for 1 hour, so we have to subtract that. Now the question number 5. A train travels along the track from A town to B town. A map shows the route. Okay, it is starting from A town, it is going towards the B town, and you can see here the distance covered by the train is between the towns is nothing but 220 km. It moves at an average speed of the 70 km per hour. How long does the journey take? So we know that speed is what? Speed is nothing but distance divided by time. So if you want to, if you rearrange this formula, this time will go to the left hand side, speed will go into the denominator. So this formula will be equal to, time will be equal to, we can write distance divided by speed. Distance divided by speed. Okay, and how much distance it is covering? It is given nothing but 210 kilometers, and speed is nothing but 70. So here I can rough calculation, I can write down your distance is 210, speed is nothing but 70. Okay, so the time will be in terms of the hour, because this is kilometer per hour. So kilometer and kilometer will be cancelled from numerator and denominator, only hour will be remaining. So it is nothing but 710 divided by 70 hours. And this is nothing but option number C. Remaining option you can see here 7 less than 70 by 210. That cannot be the answer because we are here it is given because the journey is not a straight line. But we are talking about the speed and distance. We are not talking about the velocity and displacement. That's why it cannot be less than 70 by 210. Exactly 70 by 210, that is the not the answer, because it is distance by speed, not speed by distance. So the third option is 210 divided by 70. Exactly, that is the answer, because we are talking about the speed, and speed is given in terms of distance by time, and this is nothing but the distance which is the actual path traveled. And more than 210, that is also not possible. So option number C is the answer. Now we will see the structure problems. Now we will see the structure problems in motion. So you can see here question number 1. A solid plastic sphere falls towards the earth, and figure 1.1 is the speed time graph of the fall to the point where the sphere hits the earth's surface. And question number 1 is that describe in detail the motion of the sphere shown by the graph. So you can see this is the graph, and the x-axis is the time axis, y-axis is nothing but the speed. The graph is, you can see the speed is increasing here, then it is slowly increasing, and at last it is becoming constant. So we had already seen this kind of slide in while learning the motion chapter. The speed time graph, if we have the speed time graph, then the slope is nothing but change in y-axis divided by change in x-axis. That's nothing but, here in this case, the change in y-axis speed, change in x-axis is nothing but time. So slope is nothing but change in the velocity divided by change in the time. That is nothing but the acceleration. Okay, so the slope of the speed time graph is nothing but the acceleration. And we have seen the different cases for the different speed and the acceleration. You can see here the the speed line is coinciding with the time axis, and that's why the acceleration is 0. For this case, the speed is increasing, and acceleration is constant, because this is a straight line. And here this is horizontal line, so speed is constant, the acceleration is 0. Here the speed is decreasing, acceleration is negative constant, because it is again the straight line. And in MCQ 1, we had already seen for the steeper line, slope is of course more, and for that acceleration is also more. So here you can see between P and Q, the speed is increasing, and it is almost like a straight line, and that's why the speed is increasing. So we can say the slope is also there. We can see the constant kind of slope is there. So acceleration is there. We can say, even if you consider this approximately the straight line, we can consider that the acceleration is there, because the speed is increasing. Here between Q and R, you can see the rate of increasing speed is decreasing. It is increasing, but slowly it is increasing. Here it is increasing rapidly. Okay? So when it is increasing slowly, we can say the acceleration is decreasing. The acceleration is decreasing over here, because you can consider this is a steeper line. We can consider this is less steep. Okay? And here the speed is constant, so acceleration will be equal to 0. So from the horizontal line, we can say the acceleration is nothing but 0. So it is we can say this is like the steepest line. Here the line becomes less steep. This is not a line, this is the curvature. We can see the curvature becoming less steep. So the acceleration is also decreasing here. It becomes 0. So we can write down step by step. First of all, we will write down over here. We can write down initially acceleration is there as speed is increasing. Okay, initially there is acceleration because speed is increasing. Okay, here you can see this is, we are talking about from P to Q. Then here we can say the acceleration is getting less than acceleration is getting less. Okay, that could be our second point. This question is of 3 points. We should at least write the 3 points. And third point, you can say the speed with speed as you can write as with speed. Speed is becoming constant. The acceleration, in that case you can write down acceleration is 0. For the horizontal line, the acceleration is nothing but 0 because slope is nothing but 0. Okay, so at least 3 points you should write for 3-mark question. So I hope you have got this question. Now the part B of the question. Here you can see on the figure 1.2, draw arrows to show the directions of the forces acting on the sphere when it is at the position shown by point S on the graph. Label your arrows with the names of the forces. So where is the point S on the graph? So this is the point S, you can see here, and where the speed is nothing but constant. So why the speed is constant? There must be two forces, there must be forces which are acting on an object which where resultant should be equal to 0. That's why only the acceleration is 0 and the speed is constant. So which two forces are acting on the sphere? We know that when the body is falling freely under gravity or in the air, we know the two forces are acting, which are nothing but the gravitational force, and second one is the air resistance. We had learned this while learning the terminal velocity. Okay. So first of all, I will show over here the gravitational force which is acting in the downward direction like this, and there must be the air resistance which should be acting in the upward direction, and we should show these two lines to be equal. Here I have shown this to be equal. This is the arrow for the air resistance, this one will be the arrow for the gravitational force. Okay, this should be equal and opposite because the resultant should be equal to 0, and in that case only we can get the constant velocity. So here you have to label, here it is nothing but the gravitational force, and this one is nothing but the air resistance. This is the air resistance. Always remember this length of the arrow should be equal because they should be equal and opposite, so that they will cancel each other and we will get the constant velocity at point S. Also, this the gravitational force should act from the center because we always draw gravitational force to be acting from the center of the mass. I am considering this as the center of mass. Though gravitational force acts on all the points of the object, but if you want to draw the single line, single vector, you have to draw it from the center, assuming that this is the center of mass. But the air resistance does not act through the center of mass, it acts on the surface. So here I am showing this arrow from the surface. Now explain why the sphere is moving with the constant speed at particular point, that is nothing moving as. So what is happening basically over here, the as the object is moving down, the gravitational force is actually initially it is greater than the air resistance, but as it moves down, what happens, the air resistance increases continuously, and at particular point, that is nothing but point S. At this point, the gravitational force and air resistance are equal and opposite. That's why it is moving with the constant speed. So we can write down over here, when the gravitational force is equal to the air resistance, the resultant force that is the total force. The resultant force is 0, and the speed becomes constant. In this way, we can write down when they are equal, the speed becomes constant, and we can write down the acceleration is nothing but 0. So that means when the speed becomes constant, the acceleration is nothing but 0. So there is no force acting on the object. Now the part D of the question. Here, use the graph to calculate the approximate distance that the sphere falls, okay, between R and T. So this we want to calculate between R and T. So let's see in the graph. We know that in the speed time graph, the area under the curve or area under the line is nothing but the distance, because the speed is the distance divided by time. So the distance is nothing but speed multiplied by time, that we are already seen in the MCQ. So here I will draw here two lines between R and T. So I will indicate over here. This is the R and this is nothing but T, and we need to calculate the area between these 2 points. So we should calculate this area we should calculate. This area in the speed time graph is giving you the value of the distance. So this is basically the area we have to draw this. We have to calculate basically this area. So this is approximately a rectangle. The width of the rectangle, that is nothing but from this point to this point. So here you can see the width of the rectangle is approximately from 60 to 100. So you can see 100 minus 60, that is nothing but 40 over here. And the length of the height of this rectangle is nothing but, you can see at the point R, it is nothing but, you can see on the y-axis it is nothing but 120. So the area of this rectangle is nothing but this height into base. This is 40, this is 120. So we can write down. So we will write down here the distance is what? Distance is nothing but distance is equal to the speed multiplied by time. Okay. This is nothing but the area. This will be equal to, we can write down, this will be equal to the area of rectangle. Area, and that is nothing but height into base, and that is equal, height is nothing but 120, base was nothing but 40. So final answer you will get over here. This value you will get. This value is nothing but 4800, and the unit is nothing but meter. So here I will write again 4800 meter. This is nothing but the distance between the point R and T. Now we want to calculate the same distance covered between the point here P and Q. So again, let's see in the graph. So in the graph you can see this is point P and Q. So P is nothing but at the origin, Q is over here. So here we need to estimate first of all what is the area over here. So this is nothing but the area, and this area is nothing but of the triangle. You can see approximately this is a triangle. So we want to estimate this particular area to find out the distance between point P and Q. Okay, so this is approximately the triangle, and the area of the triangle is nothing but half into base into height, and you can see here base is nothing but, this is covering the 3 divisions over here at the bottom. So here you can see the 10 is at the 5th division. So you can see 1, 2, 3, 4, 5. At the 5th division it is 10. So at the in the 3 divisions it must be 6. You can consider this is nothing but the 6. The time is nothing but 6 seconds. The height over here you can see it is coming out to be on the y-axis over here, and this is between exactly at the midpoint between 40 and 60. So it should be considered as a 50. So here base is 6 and the height is nothing but 50. So we can write down. So we will write down over here the distance is what? Distance is nothing but the average speed multiplied by the time. Average speed multiplied by time. That is nothing but the area, and this is nothing but equal to, we can write the area of the rectangle, that is equal to half half multiplied by base into height. So we can write down that should be equal to half multiplied by what is the base? Base is nothing but 6 and the height was nothing but 50. So that calculation, if you do this calculation, that calculation is coming out to be 150 meter. Okay. So you can write down over here 150 meter. So our speed line was not a horizontal line, and like in this case RT, it is what was constant speed was there. So I have written only the speed, but here the speed was not constant; it is increasing. So instead of that, I have written over here the average speed. Okay. So in that case, it is better to write down the average speed because speed was not constant over there. Okay, so you have to write down always the formula and then the area under the curve or under the line to calculate the distance. Now we will see the second question. So you can read here. Figure 1.1 is the distance time graph showing the motion of an object. And first question in part A, here describe the motion shown for first 2 seconds, calculating any relevant quantity. So we know that it is a distance time graph basically, and in the distance time graph, the slope is nothing but giving us the value of the speed, giving us the value of the speed. So if I consider here, if suppose this y-axis and this reference figure, if suppose this is the distance and the x-axis is nothing but the time, then the slope is nothing but the speed. And we know that for constant lines, these are the constant lines. These are the straight lines. For the straight lines, we get the constant slope, and here these are the curved lines for which we get the variable slope. So here this is a distance time graph. So slope of this line is the speed, and you can see this is the straight line. So speed must be constant. So first point we can write down always over here the speed is constant. Speed is constant, or you can write down the speed is nothing but the uniform. Okay. Speed is nothing but uniform. Now we should calculate what is the value. Okay. They are also expecting calculating any relevant value. So we know that relevant value is nothing but the speed, and we need to calculate the slope of this line so we can understand what is nothing but the speed. Here we can consider this line, this point, and we can consider these 2 points. Okay, for the calculating the slope, we always need 2 points. This is the first point I'm considering, and this is the second point. So how to calculate basically the slope? Here we can write down here the speed is nothing but, you can write down speed is nothing but the change in the y-axis divided by change in the x-axis. That is nothing but the formula for the slope. So y-axis, you can see it is going from, if I consider these two red dots on the y-axis, it is going from 0 to 5. Okay, so change in the y-axis, that is nothing but the change in the distance. We can consider this is nothing but 5, and change on the x-axis, it is going from 0 to 2. So it is, I can write down 2. So 5 divided by 2 is nothing but 2.5 meter by second. So our slope value is nothing but 2.5, that is nothing but speed. So here we can write down the average speed is 2.5 meter by second. Again, the speed is not constant, it is increasing. So instead of writing down the speed, it is always better to write down the average speed. Okay, so we can consider the average of all or average of this entire line, that is nothing but the slope of the line, that is nothing but 2.5 meter by second. So we have to write down 2 points for the 2 marks. Now the second part, you can see after 2 seconds the object accelerates, and on figure 1.1 sketch the possible shape of the graph for next 2 seconds. So here the main important point is nothing but the object is accelerating. So you can consider at this point, this is the distance time graph. So the slope is nothing but speed, and speed is constant over here because this line is nothing but straight line. We know this for the straight line the speed is constant. So for first line, we can consider for this first line the speed is constant. So for the constant speed, we know the acceleration is zero. Okay, or acceleration is zero. And here we want to show the line for which the object is accelerating. So object when it is accelerating, the speed should increase continuously. Okay. For acceleration, what should happen? The speed should increase continuously, and in this graph, the speed is indicated by the slope. Speed is indicated by the slope, and that's why I should draw the line for which the slope is basically increasing, so that if the slope is increasing, the speed will increase, and as the speed increases, there should be acceleration. So we can draw the line from this point like this. So it should not be a straight line, it should be like a curve, and it is moving like this. Okay, so we have to draw the smooth curve. It shouldn't cross this graph basically, so I should uh, rub this part. Okay, so this way you can draw the diagram, and you can see this is the curve line, and here it is not vertical. The line should not be vertical, because if it goes vertical at this point, then the speed will become infinity, because the vertical line, the slope is nothing but infinity. So it should not be vertical. You can see this for this line, the slope is continuously increasing, because the line is becoming steeper, and as it is becoming steeper, the slope is increasing. Slope is increasing. That means the speed is increasing, and as the speed is increasing, we can say the object is accelerating. Okay, so that kind of line we should draw. So here, the part B of the question, describe how the distance time graph shows an object that is stationary. So we know that when the distance time graph, the speed is nothing but the slope is nothing but speed, and for horizontal line, we know the slope is nothing but zero. So speed will also become zero. So we can write down here for any horizontal line, for the horizontal line, or you can also write down the line which is parallel to the x-axis. Okay, the speed becomes zero. I'll write down for the horizontal line the speed becomes zero. Why it is becoming zero? Because slope of that line is nothing but zero. You can see here, this is the reference diagram. Here the part C of the question. Figure 1.2 shows the axis for the speed time graph, and on the figure 1.2, draw the first question, the graph of the motion for first 2 seconds as shown in the figure 1.2. Okay, so this is a speed time graph, and this was nothing but the distance time graph. And for the same graph, we have to draw the line for the speed and time. Okay, so how to draw that line? We know that for first 2 seconds. Okay, for first 2 seconds of this graph, we had calculated the slope, and slope is nothing but the speed, that is nothing but 2.5. So for the speed time graph, we should know the value of the speed that we have already calculated for first 2 seconds, and that is coming out to be 2.5. So in this graph, we should draw only the line for first 2 seconds, that should be equal to 2.5. So here you can see this line is this is nothing but 2, this is 4, and there are 5 divisions between this 2 and 4. So each division should be equal to around zero point 0.4 we can consider. So here 0.5 will be coming close to like this. Okay, this should be equal to 0.5, which is just the above the first division, and that line we should draw here till the 2 seconds. Okay, so that we can consider as the 2.5 over here, and this is for 2 seconds, because this is nothing but the value of the slope of the distance time graph, that is nothing but the speed. Okay, so our first question is done over here. The second question, and an extension of the graph for next 2 seconds, you can see here, showing the object is accelerating at 2 meters by second here. So how to draw this kind of graph? Okay, so this is a speed time graph, and we know that in the speed time graph, the slope is nothing but the acceleration, Okay, so acceleration is change in speed divided by the change in time. That is nothing but the change in y-axis divided by change in x-axis. So that acceleration is what? That acceleration is nothing but 2. So we already know that acceleration value should be equal to 2, and we also know that speed time graph, the slope is nothing but 2. Okay, the change in speed, sorry, the change in the time also we already know that is nothing but 2 seconds. Okay, so this value we know that is nothing but 2 seconds. Okay, so we know that acceleration is what? It is nothing but the slope of the graph, so that is nothing but 2. The denominator also we know that is 2. So what should be the numerator? It must be equal to how much? It must be equal to 4. Okay, the change in speed must be equal to 4, so that 4 divided by 2 will be giving us the value of the 2, that is nothing but the slope. Okay, so from this calculation we can estimate the change in speed should be equal to 4 in the graph, and this is nothing but 2.5. So the change should be 4, so we should add 4 to this 2.5 value. So we can consider the 4 plus 2.5 is nothing but 6.5. So our next value should be over here. So our graph should go from this 2.5 value to this, we can consider the 6.5 value. And where should the 6.5 occur? It should be, you can consider over here, it should be up to this line, that is just above this first division. This is a 6, and every division is about 0.4, so first division is 6.4. Just above that first division, here it will be 6.5. So here I have taken this line up to this point, that is nothing but 6.5, and on the x-axis you can see it is nothing but 4. So on x-axis it is going from 2 to 4. So difference is how much? Difference is nothing but 2. And when on the y-axis it is going from 2.5 to 6.5, so difference is nothing but the 4. Okay, here the difference is nothing but 2, here the difference is 4. So that if you calculate the slope considering this point and this point, okay, these 2 points, the slope will become 4 divided by 2, and that ratio is 2. That is nothing but acceleration. That was our demand. Okay, over here. So this way we can draw the second line. So the D part here describe how the speed time graph shows an object that is stationary. Okay. So when it's showing the stationary, we had already seen when the line is coinciding with the x-axis. Okay. When the horizontal line is there, which is coinciding with the x-axis, when the speed is nothing but 0. When the object is stationary, whenever we get the speed is equal to 0. So for that we can write down the horizontal line. It should be the horizontal line, horizontal line at 0 meter by second. Okay, horizontal line at 0 meter by second will indicate the stationary object. You can also add one word over here, that is nothing but the straight line, horizontal straight line at 0 meter by second is indicating the stationary object because the speed is 0. So if you want to draw on this line, it should be exactly on the x-axis basically. Okay, so because on the x-axis the speed is 0. So I hope you understood this question. We are going to end our questions over here. Thank you so much.